Alright, so in this video we're just going to be looking at LeetCode number 1365. The question is how many numbers are smaller than the current number. So it says given the array nums, the method's taken in this integer array nums. Here you see on the right, for each number at index I, find out how many numbers in the array are smaller than it. That is, for each array element I, nums I, you have to count the number of valid j's such that j is not equal to I. So obviously you don't want you're not comparing the same number to itself, and then nums j is less than nums I. So again, the numbers have to be less than the number that you're analyzing. So let's take a look through the example here on the left. Input, so this is the nums array that you'd be getting in and taken into this method. You want to output an array of the same size, but in place of the indexes you're going to have the count for the number of items that in the input array that was less than that particular item. So for example, in the input array, the number 8 here, every other number is smaller than the number 8, and this is going to be the maximum number of items that's smaller. So it's going to be I. So let's say it's 5 numbers in this array. We're going to have every number but obviously the number itself, so you're going to return 4. And so same thing, for example, here it lists, so you're analyzing number 1. There's nothing smaller than number 1 in this array, so you return 0 in that index. The number 1, or I'm sorry, the number 2, we'll give an example here. So there's a duplicate of the number 2. We're not going to count those. So 2 is not less than 2. We're going to have every other number except for the number 1 is less than 2. So for these two, it's going to be the same return number. And then similarly for number 3, you're going to have 3 numbers here that are less than it. So 3 replaces in the index. So there's a number of different ways I guess we can go about doing this. A simple way would just be to iterate through 2 for loops. So you'll start with one number, analyze every single number in the array, comparing, and then update the count as you're going through the second inside loop and fill in a return array. So we'll go with that round first, and we'll talk our way through that, and then we'll just see if there's any way we can give a better solution here. So I'm going to do my solution in C#. This is going to be very, very similar to Java, pretty similar to JavaScript. You'll have access to different things, but C# is going to be a pretty standard or easy language to read the way we're doing this. So let's start by just making the second array, the output array. So I'll just do in the comments output / return array. So we'll do an integer array that we call answer. It's going to equal, we'll just declare it with the same, it's going to be the same length as the nums array. So in here we'll declare nums.length because we want those to match, and then we'll start our for loops off. So we'll iterate through each number, analyzing them one at a time, and then for each number we're going to analyze it. We're going to look at every single array number and decide if it's equal to, less than, or greater than. So rise less than num.length I++. So a really basic for loop here. We're going to do one more for loop very similarly, choosing a different variable here. So inside the loop, we're going to, first of all, we're going to want to initialize a counter as well. So I guess for each number, we'll set the counter in the outside loop, if that makes sense. So we'll do integer count. We're going to set it to 0 to start. And so that's how many we're going to start by, assuming that there's no numbers less than it, and we'll increase that after every number that we get. In here, we want to move the counter only if the number that we are looking at is less than the number in the outer loop. So nums with index I, that's going to be the number that we're actually analyzing, and so we want to see, with reference to that number, how many numbers are smaller than it. So, for example, if we look at num j, which is the one that we're going to be comparing to our reference one, if that's less than nums I, what we want to do is take our counter and increase it by 1. Any other circumstance, we don't want to move the counter. So for example, if let's say we're looking at 8 in this example array on the left here, 8, let's say integer I equals 0, the first time we come into the loop, initialize our counter, we're looking at num I, so this is the index I, which is going to be 8 in this array, the value is going to be 8, and let's say we're also starting with our first iteration in the second loop, we're going to be comparing 8 to 8, that's the same number, so we don't want to count it. And then similarly, if we're analyzing 2 and 2, if we're in this part of the array, we don't want those to update the counter, and then obviously anything greater than that, we don't want to update the counter. So this is how we'll update, and then anytime, so this ends this for loop here. Once we're done analyzing the number in the for loop, all the numbers, we will go ahead and update our answer array. So we're analyzing the ith position, in the outer loop, and we want to set it equal to the count that we just updated. And so there's that loop, that ends the outer loop. And so the final thing we want to do is return array, so return what we refer to as answer, and put a colon. So we have 2 for loops. This is a really naive solution. It's going to be O of n squared time complexity, so it's not going to be very quick at all, but this is just a quick solution to figure out how to go about solving the answer. So we'll run the code here in LeetCode and see what it says. So we're getting an error here. It's some type of syntax error. Let me track that down real quick. Okay, so we're just referring to nums incorrectly. That's the input array name. We just kept saying num instead of nums, and so we want to do the same thing there. All right, that should solve all our stuff. So another error down here. It does not contain definition for length. Okay, so in C# the length property off of an array is capital. Alright, so maybe one last shot here. Can we get through with no errors? Alright, so that answer was accepted. The output was the proper output. So we can submit this answer and see how it compares to the other answers in the solutions. So as far as memory usage, it's going to be better than most of the solutions because we're literally only using one other array of the same size. So that's really not too bad, but as far as the rest of this goes, we're faster than only about 23% of the other online submissions, and that's because we're just literally iterating over the number of items in the array in a nested for loops, so it's going to be n squared time complexity. So let's see if we can try to get this answer any better, any faster. Alright, so for the optimized solution, I don't even know if I fully understand this yet, but I'm going to try to talk through it and see if it makes sense. So basically we need 2 arrays, separate arrays. So let's start with one here. The first one is kind of going to be a frequency count of any of the numbers. So if you see on the left here, the values in the array, so these values 8, 1, 2, 3, the values that come in the array are anywhere between 0 and 100. So we need an array to keep basically the number count, and it's going to be the size of all the array of numbers that it can be. So we're going to need 101 numbers to store all 0 through 100 is 101 spaces. So basically we need 2 arrays of that size, and so the way we're solving the problem is going to be using this kind of like counting sum method. So we need these 2 arrays, then the actual meat of the code is just going to be a bunch of for loops that aren't nested. So we're going to need 3 separate for loops so that the time complexity is O of n, although we're adding another array structure here in the storage, it's going to be a lot faster of a solution. So this first loop is going to go through the entirety of the input array. So the nums array, we're going to analyze every single number, and we're going to see what value is there. So for example, if we have this input here, we get the value of 8 is at the first index. In the num count array, we're going to basically it's going to be a tally mark essentially. So we're going to say the 8th index of num count, which is kind of going to be keeping track of the value 8. We're going to increase the value at that index of 8. So then the value of this is going to correspond to the index of this, and then the values in this array are going to be a count of how many occurrences we have. So let's start in that for loop. So we're going to go through the whole input array. We're going to increase all these counts, and now we're going to have an idea of how many occurrences we have of each number. So that's the first for loop. Second for loop is going to be the running sum. So this one is going to have to go from starting at 1, and then while it's less than the 101 cap here of the amount of numbers we can, possible numbers we can have. And so the way it's going to work here is going to use the sum array, that's secondary storage, and it's going to equal whatever we have, basically the occurrence in this array. We're going to need the occurrence of the previous array, or of the previous value. So we need num count of I minus 1. We're going to need to add it to the sum of I minus 1. So basically we're keeping a running total. So let's say we have 8 stored in here. We have the occurrence of 8 now equal to 1. When we come in here and analyze the number 8 at the 8th index of the sum array, we need it to be however many 8s we had added to whatever value in the sum we already have here. So it's going to be a running total of all the sums of the previous numbers as well. And so that is that for loop, and then the final for loop is going to be, should give us in the order that we have the indexes here. That should give us the correct answer. So let's try to run that and see if that makes sense. Yes, so it did run. The runtimes, I don't remember the runtime from the previous example, but let's go ahead and submit it, and then when you submit it, it gives you the runtimes. Okay, perfect. So we've gotten a little bit behind here on the storage, but it's definitely optimized for speed. So now we're running faster than 97.5% of the other submissions. And so I'm just going to leave it at that. There's other ways to do this, hashing methods and different things that are going to run faster and use less storage, and there's probably methods that you can do using this running sum with less storage here, but that's going to be the last solution that I update here. Thanks for watching.